All right, so I am recording now.
Oh,
Uh,
we're talking about Transformers.
yes, we're talking about the Transformer library, which is
I mean,
currently phased.
that's the technology that powers every large language model in existence.
That's correct. That's correct.
Not
That's
the not the not the action brand.
no, not the movies and everything, right? No.
If it
Yes.
wasn't obvious.
Right, yeah. So Transformers, I mentioned in the first lesson, is an architecture for neural networks, right? It's an architecture that helps the networks to have context. Transformers were originally created for natural language processing, right? And the previous models that were used for neural networks to process uh, text and make sense of text, natural language processing. That's what the word is. Didn't take into account the context. It was difficult for them to understand what is the meaning of one word in one context and what the same word in a different context, right? So transformers architecture added something called attention, which is basically a way to keep track of the context for each word, right? So each word now, the word in a sentence, for example, would have when, for example, you said the word it, right? The it, it. What does it refer to? To the subject or to an object, right? So these transformers more or less put what they do. They create tokens, which are numbers, right? That kind of put probabilities to decide what in a given context what the meaning of the word or what the word is referring to, right? So basically, this transformers library help neural networks to be aware of the context for all the words, right? And that changed everything. That changed everything because before it wasn't easy to for neural networks to understand context and make more sense of the language. Uh, Again, that took natural language processing to a next level. But the thing is that basically almost everything can be modeled as a language, right? Images, audio, everything in somehow can be modeled as a language. And the Transformer library has been able to create these models that can process now different things, not just text. We're talking about video, images, audio, using the same technology. And that's very important because before, you remember, every field of artificial intelligence, we are talking about robotics, natural language processing, computer vision, every field, subfield of artificial intelligence was developing their own technology, their own way to do things. But with the transformer library or these large language models that we are called nowadays, basically almost every field put their eyes on transformers, large language libraries, sorry, and now almost everything has been modeled as a language using the same technology. What it means is if people works on making these large language models, technology behind that better and faster, right, more reliable, this technology can be used for all the fields of artificial intelligence. I'm talking about natural language processing, computer vision, robotics, etc. So that's how I think AI is progressing very fast, right? Because the same technology, just adapted to the different problems, is working well, right? So now we have models that are multimodal. That means that they understand text, but they also understand video. They also understand audio, right? So they are getting very good. And the same technology has been used for things that, for example, drug discovery, DNA testing, So many things have been modeled as language, right? And the same technology can be used. So that makes things moving very fast. Anyway, so then here goes, so we were talking about the transformers, right? The transformers, it's originally, as I mentioned, was a way to process natural language process, right? Text, basically. And the most important thing that allows to do the training in parallel. So now you have a lot of computers, right? Like Google does, clusters, of different computers. You can train your neural network, right? Using different computers at the same time, which translate into speed. You will see later on when we start doing machine learning, you will see how the hardest part, the thing that takes more time is the training. That means creating the models, right? And using parallel computing, it improves the speed of doing the training, right? And create these new models. The second part is something called transfer learning. So what you do is that you might have originally a model, right? A model that was created with this technology. And then the same model can be used or tuned to do something different, right? This is something very common, right? So one story that I like to mention is that, for example, in Japan, right? So in Japan, they were doing um, they do the transportation system, the trains is very efficient, right? And they built a lot of trains, but there is also some areas where there are a lot of mountains, right? And so the trains have to go under the mountains and they have to do tunnels, right? So they have the technology to do the tunnels fast, but there is a bottleneck, or there was a bottleneck. They require a geologist, a person, a very expert person who can go and check the construction site and check for the rocks, check the type of rocks, the type of soil to provide advice of what kind of tunnel or what technology or how the tunnel should be dig up, right? But because there were few people, few experts that can do that type of job, the process was very slow. So there was this case where they say, okay, the job these people does is basically analyzing, identifying the rocks and the soil and provide this type of advice. I think that's a job that machine learning, right, can be done. They can be done by computers. Computers can check pictures of the soil and the rocks and categorize the type of soil, the type of rocks, and then we can take the decision how to dig this, right? So what they did, they took an open source model that was very good to recognize objects. Is an open source network. I forgot the name, but it has a number 52, RAT 52, something like that. RAID 52, I think it's called. So they took that model, and what they do was to do this thing, transfer learning, right? So you just tweak a little bit the model so that they can learn the model learns to now recognize rocks and soil. And it was more or less a fairly easy process. And then the system was very good at recognizing soil and rocks. And basically, the job of the geologist is just to revise that the outputs that from the system are correct. So the geologist doesn't have to go anymore to the site. So he can supervise remotely if they send them the results and corroborate the type of process that requires the type of soil or rocks, right? So this is called transfer learning, and it's possible because of this kind of technology allows to do those kind of things, right? So later on, we're going to do an example about transfer learning so that you can see how you can tune or change the behavior of some models that we have, right? So that's sort of the main two things. The other thing is that you mentioned, Collins mentioned, right? So transformers are basically the power of all these modern applications like chatbots. So GPT, for example, I mentioned in the first class, GPT is the word GPT. The T on GPT stands for transformers, right? And the P is pre-trained. So generative transformers, transform pre-trained, right? So this is the GPT is a transformer. Basically, it's a large language model that uses the transformers technology behind, right? So basically, most of the large language models use this one. And then Hugging Face, I introduced that last week, right? It's this repository where you can access to these models and tools for deployment, right? So there are already people who is building these models, right? And they make them available to you. Some of them are free and they allow you to do certain number of requests, right? So processing. Some others are private and they are behind a paid wall. Very good, right? So that if people wants to create applications for profit or for or real type application, real problem applications, then you can use those models, but you have to kind of pay a fee for using them. But anyway, so we're gonna tap on the free version. Some of them are pretty good, right? Um, so we are going to start with some patterns, some work that we are going to do, right? So we are going to see five patterns, different today. Not today. We're going to start with three things today. And this requires to do a couple of things. Well, actually, we're going to do three different things, and the pattern or the way we work is like a workflow here, right? So you have to define what type of task you will do. And in this case, tasks, you remember, let me go to Hugging Face. I think you can see my Hugging Face page right now, right? So, well, a second. Give me 1 second. Um, I cannot have my monitor in the other. 1 second, please. So you remember Hugging Face model, right? So the models, right? When you click on models, you can see the tasks. They have text generation, any to any, but you click over here, you will see that there is uh, more than 44 different types of tasks, right? Robotics, graph, machine learning, tabular classification, text to speech. There is almost a model for anything you want, right? Uh, Now, there is also here give me 1 second. This is the number of parameters, right? So there are models, huge models, right? Like they have more than 500 billions of parameters. That means the parameter in this case means the size of the input layer, right? So you have huge neural networks, right? Some of them are less than 1 billion, right? And then you depending how much you want to use, you can decide how many parameters you can do, right? So small models, you can use something like this. If you don't care about that, you can see all the models that any size that you want over here, right? But that's okay. So the first thing is define the task. What kind of task? We said, well, I want to do text generation. I want to do image to text. I want to do image to image, right? I want to do sentiment analysis. I'm going to do zero-shot classification or object detection, right? So last week we did something called object detection, right? So we were able to determine what kind of food was on the images, right? So we did something like that. Now, the next thing, so you find the task, you have to find the model. What kind of model you want, right? So when, for example, you said I want to do text to image, right? So okay, so these are the models that do text to image, right? So here you have different options, right? For example, here, where is it? This is when it was updated. This is the number of downloaded, right? This one is the provider's availability, and then the likes, how many likes. Some other cases, they will tell you how many parameters they have. So you can actually click on each model and see the card. This card tells you more or less what it does, how it works, right? So you can see this image to text, and it tells you how more or less this works, right? So that you understand what kind of output you are going to get based on this. And some requirements, right? Some requirements. So this is the card where you can see if whether or not it can help you to identify whether or not the model is what you are looking for, right? And then you now the third step is how to use the model, right? So there is one way that is very fast. It's called pipeline, right? I think last time we did a pipeline. This makes your job very, very easy, right? So we'll do an example about how a pipeline is. And then the other one is like a more basic way where you have to select the tokenizer and the model, right? So this is perhaps the more uh, raw version to work. And then after you decide whether you do a pipeline or you do it kind of manually, right, or basic, then you have options to package your application or your application for users. One of the things we can use is Gradio. We're gonna try that today. Gradio is basically a system, right, that allows you to create an interface, a user interface, and a web like a web application that uses the model you tuned, right, the model that you consider, so you make it available as an app for users, right, and you can host it on Hugging Spaces. Hugging Spaces is going to be a topic for another day, but today we're going to talk about radio, and you can see how simple or how easy you can actually can um, start or do a simple application. Okay, there is. So, any questions so far? Any comments so far? I am trying to open my other computer to know whether or not somebody's putting comments or something like that. Come on. All right. So let's start, right? So the tasks, different tasks that you can do, for example, uh, text classification, right? So you can classify a piece of text and in different categories, right? For example, you can have a piece of text, and you can ask, is this an academic text? Is this about sports? Is this about medicine? Is about whatever, you know? Zero shot classification also does a similar thing. You classify text in categories that you already put. This is called name entity recognition. Name entity recognition. Basically, you give it a text and it explains what parts of the text are what kind of entities, like a person, a place, an institution, an organization. Recording in progress. Different things, you know. So we're gonna try this today, right? The models that the model last time we used different. I think we used two different models, right? So you get, for example, for name entity recognition, you can use this model, Bert, Stilbert, or Roberta, right? And for summarization, we can use this one. For generation, that means generate new content based on the text. You know, it's more like a GPT. And then for rack, we can use this part, right? Okay, so instead of keep talking about this, I want you to go to Brightspace, right? So to go to your Brightspace, where is my Brightspace? Here. And find lab number 3A, right? This lab is what we are going to work today. What I did, I gave you three different notebooks. So download these notebooks. For example, let's start with this one, right? So I download this notebook. I'm going to put it on my documents, 4973, 2026. And I'm going to create a folder called Lab3, right? I like to do that so I can find them and have it organized, right? Most of you when you click, it's going to go to downloads, and then your downloads has God knows what, a lot of things. So I like to put them in a folder where I like, right? And the next thing, I want you to go to Colab, right? So we're going to open on Google Colab. And we are going to upload this one, right? So I'm going to go to browse, where is it? Documents, lab 3, and into the Hugging Face. All right. This is the first code. Please thumbs up when you are here, and I'm going to explain to you what we're going to be doing. Thank you, Jaden. Hey, Jaden, are you my student on the other class, CET4773?
Well, pretty sure this is the first time I've had you.
Okay. Oh, all right, all right. No, yeah, I have another Jaden. Okay, thank you. Ronnie is ready. Who else is ready? Hank, excellent. Well, most of you are ready now, right? Oriana, Alejandro. Tomik is ready too. All right. So what is this, right? So we're going to start working. I was going to use the word messing, but the word working with the transformer library, right? Last week, this is not new for you because last week we started doing something like this for food recognition, right? So let's start. Let's go by steps. So let's put comments to this part, right? So let's put a comment to this part, right? So let's leave only the first part. So what is this, right? So this is kind of a way to see how the models work, right? You remember that I told you these models are neural networks, right? And they are good about guessing the next word, right? So you'd give them something like a AI in education will, right? They are very good at guessing what word will be good after will, right? Will AI in education will prevail. AI in education will, change. AI in education will die. Whatever, From all the text that these models were trained, they have learned how this what word can be fed or fit in for this sentence after the word will, right? Now, the way it works, I want you to remember something, computers are not good with text, actually, right? So they are very good with numbers, but not with text. So in order to process all this information, the text, right, that was given, they had to convert these words into numbers. Numbers that then can be used by the computers, right? By the machine, by the neural networks, right? So that's what this thing does, So, well, before that, right? So this is the setup, right? So we are from the Transformers library, which is provided by Hugging Face, right? So you right here in Colab, the Transformer library is already installed, so you don't have to install anything. But in some environments, like for example, you download this notebook and run it locally using, for example, Visual Studio VS Code, Visual Studio Code, you might need to install the Transformer library, right? So this line that we have commented over here is to install the Transformers library and all the elements that we are going to use into this environment. But we already have it installed in here. So that's what I like to use Colab because it simplifies the ways that we work, right? So we don't have to install anything. It's already pre-installed. So here we are importing from the transformer library. We are importing auto tokenizer. We are importing auto model for causal LLM and pipeline, right? So the first thing we are doing is kind of the basic way, the way that manually you can work with this, right? So first we select the model, right? So we are using this model over here. And by the way, check what this model is about, right? So you can come over here and in Hugging Face and tell me what is this, So look for this for SSH Lifier Tiny GPT, right? So this is the model. Doesn't even have a card, right? But it's a very tiny version of GPT-2. Very simple, right? Actually, it's a really bad large language model, right? But we are going to try that, and then your job will be to find out what other model can be used, right? All right. So the first thing, we have our model, right? This little model, and then we create an instance of the tokenizer. What is a tokenizer? Basically, the tokenizer is a technology, right, that is going to convert each word into a token, into a number that now it can be used by the computers, right? So remember again, computers are not good with numbers, right? With text. So we have to transform it into token. So for example, AI is going to get a number, let's say 503. In is going to get a number 102. Education is going to get a number 572. And Will is going to get another number. Those numbers are already kind of somehow already predefined on the models, because you remember these models know every word, right? So they have kind of a number for each word, let's say, is the numeric version of each word, right? Or token. So, and then this is the tokenizer. So that's the tool that converts words into numbers, right? And then this part, the second part, the auto model for causal LMs, right, is the one that uses the model, right, to for the task that we want. In this case, is for causal. That means is a model that can generate text. So you give a word or a sentence, and it tries to find the words after that can fit on the text. That's what it does. This is the model, which basically is text generation, right? So then once we have the tokenizer and the model, right? So we have the prompt. The prompt, remember, is the instruction. So, or the text that you want to use this one. In this case, we said AI in education will, and what we are looking for is the system to complete the sentence, right? AI in education will something, right? So here is the prompt. And then what we said we do first on this line is tokenize the prompt and return tensors. Tensor is basically a fancy word for like a matrix, right? And PT in this case, it's telling what type of tensor, what type of matrices with the tokens, right? So it's gonna return something like a list, similar to a list with numbers for each word, right? But these numbers can be in different format. PT stands for PyTorch. Right now, in this time, there are two big frameworks that are used to create neural networks. One of them is called PyTorch and is owned by NVIDIA, the company who does the GPUs, right? The other one is TensorFlow. Does anybody know who owns TensorFlow? Have you heard about TensorFlow?
Google.
Google, right? Google is the owner of TensorFlow, right? So there are two of them, and each one use their own kind of version of tensors or matrices, right? So here the model is saying return tensors in format PyTorch, right? In the background, all the transformer library uses PyTorch tensors, right? So now here inputs is going to have converted all these things into numbers, right? So maybe you can see that over here you can display inputs, right? So, and then you will see later on what are the values that are done. So we can put actually the yeah, so that's are the tokens. Then we use the model, right? So here is our model, right? And we are telling, hey, generate text using these inputs. This is a way to tell the inputs are actually in a format of dictionary, key vectors. You will see when we display the inputs that you have a key and a value. So basically, this is the format in which the inputs are gonna eat, right? And then it says max new tokens, 30. So the maximum number of tokens is 30. So you want to complete the sentence with a maximum number of 30 more words. So the system is gonna kind of repeat the generation 30 times. It's gonna generate 30 new words, correct? And that's it. And whatever the system generates is gonna be stored in outputs. So outputs is gonna have now the new sentence with the words. But right now, still they are numbers. They are still numbers, So remember this: the models work with numbers, so they are still numbers. They are tokens, right? So before we can actually see the actual words, so we use the tokenizer, but now we use decode. So we're gonna get the input, right? And convert this, whatever we have on the outputs, whatever that we have on the outputs, on the first element of the outputs, we're gonna decode it so that we can actually print the words, right? So you run this one right now, you will see something like this. The first time you run it takes some time because, by the way, you see something like this on the bottom, right? It says you specify the settings for runtime, right? So you can just leave it running like that, or you could have changed the runtime and add a GPU. Right now, we're gonna use it by default, and then we're gonna try to use the GPU to see how we notice some difference, right? The first time takes some time. It takes some time. We saw that last time, right? It takes some model. And then this is very verbose, very, very verbose. You see, I have a lot of things. I have a typo. I have a typo over here. Display. Why display is not working?
You wrote display
You, right?
I had display you, but now I put display and it's not working. Display
Oh,
should
still not
work.
working.
Oh, it's still not working.
Yeah, and I think it's working now. Let's see how it works. Yeah, I had a typo. Now it works. Yeah. All right. So look, here is the tokens, right? These are the inputs, the tensors or tokens. So you see, we have numbers. These are the tensors. So AI is this number, in is this number, I believe, education is this number, and will, this is number, right? At the end of the day, you don't care about this, because whatever you want, you don't want to see this number, right? But I'm showing you what's happening on the back. It's very important that you become a knowledgeable user of these things, so you know what is happening on the back end, right? So now these words were converted into numbers, and then we have this thing called attention mask that, to be honest, I don't know exactly what it is, but these are the tensors that contain both things. So these two elements make these tokens, right? So the next thing we did was to this is what we did with this line, right? So we print the tensors, right? Then we did the output, and then we print the output back, right? So after it was completed. Now the model we are using is really, really bad. You see, it says AI in education will stairs. The same word. It's very dumb model, right? It doesn't do well. So your job right now, the first job you have, is to find an alternative model, right? to do a little bit better than this, So find another model that for text generation that you can use and replace this one. Can you do that? And let me know what model and how did you find that model, all right? So that's the first job. Make this thing work, right? Finding a different model. Is that clear? Yes, no?
You want us to find this text generator?
I want you to find a new text generator because the one that we have over here, you see the results over here, it's really bad. It only generates the word stairs, right? Stairs 30 times. Because I said 30, it created probably 30 times or so the word stairs. It's really bad. So this example that I told you that we to use this model is really bad. So I want to replace it. I want you to replace it for a new model that can do a better text generation. That's the word that the first thing we want you to do. I want you to do. Show me your thumbs up when you are done.
Did you ask us to replace the model?
Yes,
Okay.
exactly that. That's what I asked, right? To find a model, replace the model with one that actually does a decent job. Okay. If you are confused, you don't know what to do, don't hesitate to ask, right?
So, Professor, you said find the model name and what and like change it.
Yeah. So this you see, this is the model I am using right now, right?
Yeah,
Right? So
yeah,
I want this is the model, right? So this is the card on Hugging Face of this model, right? Obviously, this model is trash. You see, what it does is really bad. It only returns the same word, right? I want
yeah.
you to find a model that does text generation and works well, right? So one thing you can do is come over here, right, and find here the task that is text generation, right? And find one of those models, replace it. A very simple thing, replace the name of the model, right? Run it again and evaluate whether or not the model works well. If it doesn't work, find another one, right? And then
Oh,
until you find that you feel, that one actually works, right?
yeah.
You can try more than one, You can try more than one and tell me what did you find.
Oh, okay. Thank you.
You are welcome. Nobody has done it yet?
Mine's is downloading. It's still taking
It's
a while.
fetching data from the database, I think.
Okay. So yeah, first sometimes takes some time, right? But there are some of you that already did it. Um, I don't know. If you did it, I want you to put in the chat the model you picked, the model you selected, and the output. I mean this, right? The string, you can copy this string, the string that was created with the model. So basically you can put in the chat something like this, right? Say model, and then you put a colon and the name of the model, and then you do output. Something like that. I put that example on the chat, right? So actually it should have been, I type it incorrectly. Output. All right. Oh, now it's good. Right? So I want you to do that. If you are done, I want you to write the name of the model you use and the output you generate. Perfect. Okay, Daniel. Uh, Daniel, I just want the string, not the whole thing. You see in my screen, this is the output that I am looking for, right? So because AI in education will, and I was looking for this part. I just want the last string, not the whole thing, just the last part, the actual output in text format, right? You see what I selected? That's what I
Yeah.
want. Can you do that?
Okay.
All right.
No problem.
Thank you. Like Mohammed. Okay, so you use the tiny llama. Okay. In education will have a significant, more efficient and effective way to learning. Yeah, okay, that's good. Can use something called Quen 306. Uh, okay, and the output is is interesting, right? Um, all right. So I have two examples so far. Well, actually three with Daniel. Anybody else? Now remember things, these models, these models are probabilistic, right? So they still the way they guess the next word, right? Every word has a probability, right? But still they do it a little bit random. They decide what to put over there, drawing a random I mean, sorry, a random distribution, right? So even if you run it again, right? Maybe the second time the words that it gives you might be different, right? So you happen to use one of these the models that some of your friends or your classmates have used right now, you might get a different output. And that's something interesting that I want you to look at that. These models are probabilistic, and not deterministic, meaning that they don't behave the same every time, right? Is anybody having a trouble with this? Yusuf, but you said that you are still loading a good one. So you pick one that is big, 20 gigabytes, 32 gigabytes. So that's another thing. Is anybody else? Collins, how are you doing? Janat, how are you doing? Are you having any trouble?
No, I'm good.
They're good. So what model are you using, Janat?
I'm trying to see if it works. I'm just uploading it right now. Just like
Okay.
1 more minute.
All right. How about you, Alejandro? How you doing?
I'm waiting
Ariana
for
is
it
throwing
to,
you.
I'm waiting
Sorry.
for it to upload as well.
Okay. All right. Ariana, depending on the error, right? So right now we are not going to try to fix errors. Move to another one, right? Choose another one. Errors can be different things. It can be that the model you picked doesn't do no longer does text generation, or that is paid, or that you don't have enough space and is looking for you to log in. Many things, but instead of trying to fix right now, pick a new one so that you have this part done. Later on, we're going to go into some details, okay? So yeah, it's another suggestion that Ronnie was saying, right? So you can do something like that, so change the runtime to GPU. So that can boost a little bit the performance. So for doing that, you go over here, right? And then you do change runtime type. You can see here. And then you pick either one, T4 GPU or B6, B5E1. No, that one, the GPU. That's the only option you have, right? So you add a GPU, and then you can do this part, right? So I'm going to find a model, right? But whatever I picked, you are not allowed to use it, so you have to find your own, right? I'm going to pick this one has 522 likes and 200. I'm going to use this one. Right, so now I'm going to run it. Here it is. What is this? Okay, this one requires a token, um, requires to have a token. So let's see if it works like that. This one it's not going to work because it requires to be logged in or have a token. Means like you have to kind of log in into this, right? I don't want to do that right now. Later on, you will need to find things. You want to really use one of those, you need to go. So let's go find this one. It's called Queen Tree Next Code. This one is this is for coding. I don't want coding. This is for coding. This is for German text generation. Mini CP Sala. This one might be in Spanish. This is interesting. Let's use this one. Now let's see again. This is one kind of the same thing. No, it doesn't want. So what is this thing? So this one, trust remote through. So you have to put this over here. All right, so we're gonna use this one. We're gonna change this part. See if it works this way. So the model is this one, which is the same one. The auto tokenizer is the same thing, but now we're using this part, the same thing over here, but we have this parameter that was asking me over here, right? We'll see if this works like this. But now, displays model. So we used to call it model. So we're gonna use this one again. This is the variable I am using. So I'm gonna comment this and stop it. I say no, and then run it again. What happened? Some packages that are required. So let's see what's happening here. So it needs one. You need this thing, but I don't see that it was added. Okay. Let's see if that makes it work. No, so I think this is not going to be allowed to install. So one more that doesn't work. So let's find another one. Let's see this one from OpenAI. All right, so I'm going back to basics using OpenAI. It's going to be long, it's 112 megabytes. Right now, it's actually 34 gigabytes. It's going to take a lot of time, this one, but I assume it's going to be a good one. So how do we check how big is this? How big is this? How do we know the size? We have the downloads, we have, which is that, follows, likes. Yeah, here it is, size. 196 gigabytes. Big one. So let's see how it goes. 12%. Somebody else has finished? The last one was Daniel. Daniel, your output talks about New York City, right? But I think what you are doing is you didn't comment the last few parts, right? So you are still generating with second part. So well, that's fine. But I wanted to see how your model works with the prompt that says AI, right? So look, in the code, this part, the second part that I asked you to comment uses another way to do things, uses the pipeline, and the code and the generation that we are trying to do is Hello New York City, right? That's cool, but I was working. I wanted to see what happens with this prompt, AI in education will. So what I want you, Daniel, is to comment this, right? Run it again so that we can see what your system, your model generates using this prompt. Can you do that for me?
Yes,
Thank you. Gosh, I picked a big one, right? So I should have checked the size of this thing, 196 gigabytes. So they're big. Let's see. I would love they told us how big they are here, right? Here it is, 80 gigabytes, 80 what is that? I know that's the number of parameters. 80 billions, 80 billions, 754 billions of parameters. That maybe that's aligned with the number with the size. This is the one that I'm picking is 120 billion parameters, right? But it doesn't say how big the model is, because right now is at 39% downloading. Hopefully it works, because otherwise I just waste my time waiting for the model to be downloaded. I believe it's gonna work, right? So it's big enough for doing that. So the one that I put originally, in the I forgot the name. It is a super small one, few kilobytes. It's very small. That's why it's very bad, right? It's actually a toy one. But this one that I picked from OpenAI seems to be kind of big. I'm at 42% right now. I don't see anybody else, but Daniel, Mohammed, and Ken. Nobody else has finished this part?
I've been using this same model and it's been running for about 20 minutes downloading.
This one, you should have
Yeah.
told me, because I don't use the same one that I'm using. You told me, I'm using that one, so I should use a different one. I am tempted to stop it and find a different one. How big is this one from NVIDIA? 19.4 gigabytes. That's not too big. This one. It says that it knows everything until November 28, 2025. You know what? I think I'm gonna stop this because it's still 54% and it's 56 gigabytes. This one seems to be smaller. Daniel, thank you. I think you did already this, right? So, uh, good, Daniel. That's good. What model do you use, Daniel? Is inference.net. Okay, good. In billions of parameters. I am tempted to stop what I have over here, and use this one. How is doing? 70%. I'm gonna stop it. Somebody else is doing the same thing for a long time and hasn't finished. I'm gonna stop at this one and change it to the NVIDIA. Same thing as before. The argument trust remote control. So I'm gonna put it over there. This is slow too. And it's not moving at all. One's supposed to be very good, comparable to ChatGPT. But how big is this?
I think it's very big.
Yeah, I imagine that should be big because it's comparable to GPT, but I don't know how big it is, you know? Right, so I'm gonna log in my account. I remember. No, I don't remember, so I won't. This one didn't work because it requires some. It filled my my disk. Oh my goodness. Yeah, so this is too big. So now I have to close this in order to free this space over here, I believe. Mhm. Gosh, it's full, right? So now I cannot do anything, you know, with this thing. What happened if I just close my this one? I have never run out of a space of things like that here in Colab. First time.
I'm pretty sure you just have to close it and then reopen it to um, reset.
Most of the time, the things that I upload, they go to this folder and then they are disappear when you close it. But I noticed that there are some things from the previous one I didn't use, right? So I'm gonna do what you said, just close this one and reopen it again. I was thinking that maybe there might be something that can clean the memory. How about if we restart the session? All right. And I'm gonna use one of this. I'm gonna use one of the ones that the one that Ken used. Let's see how it goes. All right, so yeah, this one was cool, right? These are the tokens that generate, which are a little bit different of what Ken found. So maybe if you are still struggling with finding a model, you should use this one, the Quen 30 or any of these other ones that actually work. That's a challenge, finding the right model that works well and that is big enough that produces good results, right? Some of them are just monsters, right? Anyway, so okay, so can I have your attention for a while? So let's move for the things that I was actually thinking to cover. So the first time, right? So the first part, we did this, right? And I want you to understand that we kind of did all the part manually, right? So now look into the second part, right? So I'm going to put a comment into this one. And let's focus on the second part, this part over here, right? This part over here. Okay, so this one is doing exactly the same thing we did on the top, right? But we are using this feature called pipeline. So pipeline, when you use pipeline, you don't need to do all this part over here. So we do the tokenizer, we create the model, and then we tokenize the prompt, and then we generate the outputs, and then we decode, right? So we can manually do all those things. Pipeline does that for you on the background. What you need to do is just tell what kind of tasks you are doing. In this case, we are saying text generation. We are telling what model we are using, right? Right? The model is the model name, actually. And actually, we need the tokenizer. So the tokenizer is this tokenizer that we created from the model. So the tokenizer has to be related to the model. Every model is going to have their own tokenizer, right? So you said the model, and this is the tokenizer. So we're saying, hey, use this tokenizer called tok, right? This variable that we created over here. And then you see, now this is our pipeline, right? And then what we said now is to the pipeline, generate hello world. This is the prompt. Instead of prompt, we are using the text that we want to use as a prompt, right? The first parameter here for the pipeline is the prompt, and then how many tokens. And this part over here is just to select from the output that it returns the first element called generated text, because it returns several things. But this is in the first item is like a dictionary. Is going to return the generated text, right? So you run this one. Let's use the same prompt as before. Here we are going to put the prompt, right? The prompt we have over here. The same prompt is going to do exactly the same thing we did before. The output that I got before was this one. I'm going to save it so that we can see what happened. I'm going to put it here. This is the output I got when I did this part. And now I am going to use the prompt, which the prompt is AI in education will. And if I run it, it does exactly the same thing, right? So both of them are doing kind of the same thing. But this version, when we use the pipeline, is, let's say, a little bit more. It's a simple way. A simple way to do this, to do the same task. Now, let's see. It says. What is this? These are, by the way, all these messages can be suppressed, can can be silent, right? So how do we do that? So I think this is login. I actually forgot the exact command, so we are gonna ask this thing, right? So how can I silence the log messages that appear? Just like that. I think you have to import log and then tell the model to not to display anything. So those kind of things can be done. Yeah, login actually, right? So you see this part of here. You import logging, which is a library, and you said login get logger transformers set login error. So this is basically what is going to allow us to avoid all these annoying messages, right? So let me stop it here and run it again. So I'm going to get the same thing. Oh, did I miss it? Oh, here it is. Yeah, so it's going to do the same thing, but all the messages that I had over there, the log messages, were suppressed, right? So now I have this. I believe also these messages can be avoided, but this is the new thing that I generate. So this is the output, right? So compared to the other, you see, both of them start with the same thing. AI education will likely reduce the amount, and it says here AI education will soon be in the hands of AI teachers. This will change the landscape of education for the better, etc., etc. Right? So again, these systems are not deterministic, so you will get different answers different time, right? So this is the same thing they produce. This is the same kind of a process, but here you do it kind of manually on all the stages, right? So you create the tokens, you generate the output in a token form, then you decode the tokens, and then you print that, right? So here the pipeline is doing all that for you. You just have to tell, I want to do task generation using this model and this tokenizer, and then everything is done by you. Just to make sure, like for example, if I remove this part over here, right? This is going to, instead of display only the text that is the output, right? It's going to display kind of it's a dictionary, I think, that has several elements, so a JSON file, something similar to a JSON file that will have different elements. Like for example, you see, this is a list with the text. It's a list with a dictionary, so it's a very weird. Doing this little part that we have over here, right? That we have over here, we are saying, hey, from that list that you gave me as an output, this list, I want to get the first element, which is this dictionary, right? All the way to here, to the curly braces. And then I want the key generated. So this is the key generated, and this is the text that comes on generated, something kind of weird. And then that's what it displays. It displays only this part over here. So I could do that here if I add a new cell somewhere here. I can do a new cell, and then this is called. Oh well, no, because I didn't save it anyway. So yeah, I didn't save it. So I didn't assign it to a variable. So I just printed and that's it. But with this, just get us the a new text. Now you see, every time that I run it, it comes with different things. It's very random, the words that it generates. So that's text generation, right? So challenges here. I guess this is the best or the simplest way to use it is this way. So they do the same, right? This one and this one does the same. It's just that I'm showing you here that with pipeline is simpler, right? It's a way simpler to do the same thing, right? It's important for you to know the background so you can modify it. Now, your job. right? So for this lab, right? So I want you to after this, I want you to create a text a text a, a text cell, and I want you to explain what the code does, right? Explain with your own words what this code does, right? Do. I want you to write here with your own words. You can use AI, right? So for example, but at the end of the day, I want you to tell me your version of how this works, right? So for example, this AI actually Gemini, what version of Gemini we are using here? Flash 2.5 is small and not the best, but it for coding works okay. For text generation, I mean, for helping you with some tasks, is not the best one, right? So this one, the pro version is better, but I don't want you to pay for that. But what you can do, for example, is encode this, right? And ask, explain what this code do, right? And the explanation on this version of Gemini might not be the best, but if you follow the tips that I gave you to prompt, you might be able to get a better explanation. So something like that. I want to understand how this code works. Provide an explanation of the background knowledge and the background knowledge so that I understand what is behind the scenes. You can say I would like to be able to teach about this technology. Always teaching is the best way to learning, technology. So I would like to have some details. Do it by section. First, explain the basic, and then the pipeline. Something like that, right? And then you can get a better idea of what is work. And I want you to write your own version of that, So tell me how this work. So yeah, it's talking about tokenization, model loading, model inference, decoding, background, then the pipeline, right? It's not the best explanation, but somehow it helps, right? So if you want, you also can copy the code and use Copilot or ChatGPT. I think this is something nice, it's a nicer explanation of these things. For example, I did this on Copilot, right? So I put the code and I asked to explain. So this is the big picture. So manual, low level, and high level with the pipeline. So we have two models: the manual version, the basic one, the high level version, and it then explains every part of the model of the code. What is what the tokenization, the learning, the model, and the basic, and then the pipeline, right? So it explains all that thing. Actually, it's good explanation, but still a little bit for you to interpretation. I actually did the same thing with I use what you call this is Visual Studio Code, right? So the Visual Studio Code, you can run this pipe Jupyter notebooks locally, right? And I asked the same thing, you know. So for example, I asked, hey, explain this code. And this Visual Studio Code, it uses Cloud Sonnet, which is Anthropos. It's another company, right? Is actually I love the way it explained these things, you know. So first, it tells me what the is doing. Start doing a code breakdown, very nice. Tokenizer, model focus, so very similar to what GPT, Copilot did, you know. Very nice. And then I asked, well, yeah, I like that you told me about the code, right, and the things over there, but I want to know more about the basic method, right? So I'm a totally newbie in this. I want to get the background knowledge, need to deeply understand what all this is. And then it came here, you know. So it tell me, what is a language model, and it puts some example like GPT-2, right? Then step by step, what is tokenization, right? It explains very well how the tokens are breaking, the words, the AI is broken into tokens, which are numbers. I mentioned that before. And then generates the inputs, right? Generates the outputs, which are also the outputs are numbers. And then when we do decoding, right, actually it does the decoding, converts those numbers, those tokens into actual words, and then it does the rest. You know? So it's a nice explanation. I don't want you to explain this exactly or copy and paste, right? I want you to reflect a little bit if you understand what's happening, right? That's your job in this class, you know, to understand what's happening and be able to reflect a little bit. So that's why I asked you to add here in this part. After your job is to change the model, right? So that you have something running that works well, right? And experience all the nuances of, you know, looking for a nice model that works quickly over here. But now I want you to use your own words to explain what's going on here, right? So what's happening with tokenization, put a little bit background about large language models, tokens, and how this works, right? So tell me what you learned about this, right? And if you haven't learned just yet, this is the time. That's why I'm asking you, right? So you understand what's going on, so that you know what tokens are, that you know why the need to do tokens, etc. Right? So that's one thing that I want you to do, right? You don't have to do it now. You have time to do that later on. So let's then move to the next notebook that I share with you, right? So is this clear what you need to do for this part? Yes, no?
Isn't
I
it
see
like
more.
you explain exactly what is happening in the code?
Right. And the background, right? So why we do tokens, what are tokens? Yeah, exactly. What's going on? What happened, right? Especially with the basic model. The pipeline is kind of a high, upper level model, but the basic does all these things manually, right? So I want you to show me how much you understand what is happening here. Okay? Make sense? Perfect. All right. Great. So let's move on, right? So let's close this one, right? And then we are going to go to the second notebook that I shared with you. This notebook is the 02. So we are want to download this notebook. Again, I'm going to go to Colab, Google Colab, and I'm going to upload the second notebook. So now that we know that using pipelines, right? The pipeline is the simplest way to do things, you know? So we are gonna explore other type of tasks, right? So one of the tasks that we are gonna do is called sentiment analysis, right? The other one is called zero-shot classification. The third one is named entity recognition. And finally, we are gonna do summarization, right? So we're gonna do 3 different tasks. The code that we have over here does each one of them, right? So but I missed to put comments. So for example, the first one, right? It uses this model to do sentiment analysis, right? So let's do this part. So here we do this is sentiment analysis. So I want you to add these comments over there so you understand what's happening, right? The second, this one over here is for zero shot classification. It's another type of task, right? Then here we have named. This is the one called named entity recognition, or NER, right? And then the last one, it does summarization. So here, this one actually already does summarization, right? So let's learn about this, you know. So I want you to comment everything but sentiment analysis, right? So let's focus on sentiment analysis. Now, I want I want all of you to do a quick search and learn what is sentiment analysis. And then some of you, whoever is brave, is going to tell us or share what do you learn? What is sentiment analysis? You have 5 minutes to come up with a good definition of what sentiment analysis is, right? All right. So in the meantime, while you look for sentiment analysis, I want you to learn what sentiment analysis is and how it is used, right? Why I'm asking you to do that? Because maybe one of the applications you're going to use is going to use sentiment analysis. You can combine several things, you know. For example, people on the past have done applications that analyze customer feedback, right? In different to recognize who is mad or or the sentiment of each customer, and then classify the type of problems using zero shot classification, and then find what are the things that are done. They complain most using name entity recognition, and also when summarize reports, they can use those things. So you can have a whole application, very specific application, combining all these tasks, right? And combining different models too. So we are going to do the first model, right? So task number 1, search or look and a way to explain to me or to the class what is sentiment analysis, right? I'm going to take that as a participation, right? So in the meantime, I'm going to prepare so that you can take attendance today. Hold a second. So remember, you are looking for sentiment analysis right now. What is sentiment analysis? How it is used? Anything else that you want to learn and share about sentiment analysis? That's what we are going to discuss right now. All right, let's take attendance. I put on the chat the link in case you want to do it in your computer. This is the code for today, and this is a QR code in case you want to use your phone, okay?
Hey, can you post the link?
In the chat already, Collins.
What?
I put the link on the chat.
I don't see.
You don't see it? I will put it again there.
Because my phone is dead.
Yeah. Oh, I see why. I sent it directly to Isabel. I don't know why Isabel was the default. All right, so now there it is. All right, so people started putting in the chat, yeah, sentiment analysis. Okay, now, good. Several of you already have an idea what sentiment analysis. So, who can verbally tell us or share with us what sentiment analysis is? Remember, one of the things that actually one skill that you have to develop while you're still in college is uh, communication, right? So talk about this. Yusuf, go ahead.
Yeah, so sentiment analysis is like AI, it's sort of AI driven, and it just analyzes volumes of text to determine if it expresses like a positive sentiment, negative sentiment, or a neutral sentiment.
Correct.
Yeah.
So that's what it is, sentiment analysis, right? So, and how does it look like? What are you gonna get as a sentiment when you run the model? What do you think is gonna get? You are gonna get. That's one question. The second question is why or how a sentiment can be used.
So your first question was like, what was your first question again?
Well, the first question was what sentiment analysis is, and then the next question is when you run a sentiment analysis model, what exactly you are going to get, what categories, in what format, and then the third question was how all this sentiment or the sentiment analysis can be used for what purposes.
I will say the main purpose of this sentiment analysis is to get the feedback, like the emotions, what the texts are saying, the positive or the negative, or whether it is neutral.
Okay, all right, so good. So most of the time you have three values, right? You have negative, neutral, or positive, right? And then you with this you can determine what is the tone, right, of the text, right? Sometimes I was mentioning this type of analysis is used, for example, to understand customers, right? What their opinion about a product, what opinion about the service. Yeah, that was good. Yusuf, you have something else?
Yeah, I was gonna add on to that with examples like you said, companies like customers, if they let's say they not satisfied with the product, imagine like AI reading it and saying, "Thank you so much. We are pleased to hear that." Like it wouldn't make sense. So it needs to like basically analyze the tone and reply and respond in a way that would make the customer feel better.
Correct. Right. To make sense of what they are talking about in an automated way, right? So you can run these sentiments and kind of get an automated way. You could automate responses based on the sentiment, right? You can also take decisions based on the sentiment of the people that you are serving or the text that they are generated, the comments, social media, etc. Right? Good. Yeah. Okay. So I'm gonna remove the attendance, right? And now let's go back to the code, right? So, but right now, we are using the pipeline. You're not seeing the text, right? What happened here? All right, I was so confused. All right, so the pipeline, right? So we're saying the task is sentiment analysis, and we're using this model. I don't know how good this is, right? But we run the model, right? And then when we said, hey, and give me the sentiment of this piece of text. This can be a long text, a small text. It can be, for example, a post from a customer, right? Or a bunch of posts from the customers, and then you run this. I don't know how long it's gonna take. This might not be as good as we think. This is again a tiny model, so we'll see how it works. All right, so it's running right now, and finally, it's giving me a label 0, score 0.5. What does it mean? I don't even know what that means. So let's see what on Hugging Face. Let's find the card for this guy. The card for this guy over here. Put it over here. Find it. It is the card. It doesn't say much. So, for example, this label that we see over here, I don't even know what does it mean. Does it mean positive 0.5 or negative 0.5? I don't know what label 0 is. So this model, the one over here, is really, it doesn't have more information, right? So my suggestion is find another model that does sentiment analysis, right? So for example, you can find sentiment. So hopefully I am lucky and find something that is for sentiment analysis quickly. No. This one, maybe this one, right? But let me see. Because I don't know if there is. I checked before, and there wasn't a clear, what's it called? A task that called sentiment analysis. But many of the models do sentiment analysis. Sentiment by sentiment. All right, so we have this one, sentiment analysis by Thanos. I don't know how good this is. I'm going to try it quickly. Thanos sentiment analysis. I'm going to put it over here. Right, I changed the name of the model, run it. Hopefully it works. It's kind of fast so far. Well, I just picked it and I never read what does it do, right? So hopefully, okay, here, that's good. So the label is very positive and it's giving us a score of 0.60, right? So the confidence that is a very positive is 0.60. So actually, Tanaos, yeah, it tells us, we have several labels. We have very negative, neutral, positive, very positive, right? So these are the labels that it has. So right now it's telling us that this comment that I have over here, I love teaching with hands-on projects, is very positive with this probability, 0.60, right? So I can change it, I don't like teaching with hands-on projects. So let's see what is the score now. So now it's negative with a high probability, right? 0.87 is a higher probability that is negative. So it's a negative thing, right? And now I can say something like, I hate teaching with hands-on projects. And then I will have very negative with also high probability, right? So this simple thing can help you to analyze different texts and take decisions from them, right? This is sentiment analysis. Any questions about sentiment analysis? Of course, you want to know more on how sentiment analysis is done, kind of a little bit more manual, right? You can learn about that, but at the point of this at this moment is just to use a model that is able to do sentiment analysis and more or less have an idea of the interpretation of what it is, right? So good thing that this model, the Tanaos, is fast and it explains well how it works, right? That's an important thing. And if I found it fast, right? So try this one and check, do a couple of tests, right? Change the sentences. Let's see, can somebody come up with a sentence that can be neutral? You have a sentence that can be neutral, put it in the chat so that we can, I can use it here and see what happens. I learn AI. Okay, so let's say I learn AI. That was a suggestion from Ronnie. Yeah, okay. Right. So let's see what happened. Actually, it says that it's positive. I don't know. Yeah, I don't know really if this is, well, maybe learn is positive. The funny thing is it has a higher score, right? Positive score than the phrase that we have originally, right? The phrase that we have originally was this, I love teaching with hands-on projects, right? So remember, it was positive, but like a 0.5 or something like that. 0.60, very positive. Okay, because it's very positive. The one I learned AI is just positive. This one is very positive, right? Okay, yeah, makes sense. So they have different levels. That's an important thing, right? So to understand what these labels mean, right? And if you are going to do a system, you have to make sure that you understand what are the different type of or categories this system can understand, right? So good. All right. It wasn't neutral. Does it has neutral? Yeah, it has neutral, right? Something. What can be neutral? Man, my head is not working today. So let's put something. The dog is in park. I don't know what kind of neutral. It's very neutral. It doesn't say anything. So I managed to write a neutral. So Mohammed said it's cold outside. Let's see what that does. It is neutral. Very high neutral. Cool. Cool. All right. All right. So this is the task called sentiment analysis, right? So let's put a comment to this one. So by the way, to comment a block a line, you select the lines and press Control backslash, right? So Control backslash, you uncomment, or Control backslash, you comment again, right? You press it again, it's uncomment. So let's uncomment this one. All right. So now, who can tell me what is zero shot classification? Zero shot classification. It should be with a dash, right? Zero shot classification. Search and tell me what is zero shot classification. And you want to do a little bit more. How is it used, right? Anybody? But you figure out. I'm going to run this one to see if it works. Yeah. Okay. Yeah. Somebody.
I see something. It says is when your model categorize texts into things it has never been trained on before.
Yep. Yep. That's more or less like this. There are other comments over here. Asamat says it's a machine learning method where model classifies data, text or images, into categories it has never seen during. Okay, that's what you said, right? Yeah, basically that's what it is, right? So, for example, in this little code snippet that we have over here, right? So we have this is the text, right? The text that I want to classify. The text is this workshop uses Hugging Face to build NLP demos, right? So, and then you say, what kind of content is this? Is it education? Is it finance? Is it sports or health? The system wasn't trained to categorize things specifically into education, finance, sport, and health. But when you put that, it tries to see which one matches best to this category, right? And then you can see the answer over here. The sequence that we tried to categorize is this one, right? This workshop uses Hugging Face to build NLP demos, right? And the labels that I gave were education, health, sports, and finance, right? And these are the scores. It seems like the highest score is 0.75, right, for education, followed by, well, the other ones are low, right? So it says 0.1 for health, 0.074 for sports, and 0.06 for finance. Obviously, this is telling you this content over here is more likely education, right? Now you can change the categories, right? So you can say instead of finance, you can say politics, right? Politics, technology, and religion, right? Just to say one, religion, whatever you are interested, right? So, for example, you are doing an analysis of the recent publications and you want to see, let's say you're a publisher, right? And you want to see what are you want to classify all the books or the articles that have been published in the last year in 3 categories, right? Education, politics, technology and religion, right? And then you said, okay, let's see. This one, how about this one? This is one on, obviously it's going to say education, right? But what I'm curious is to see how the probability change, So you see now the probability when compared to technology, to politics, technology, and religion, right? Now is more clear that is related to actually, why? No, it's technology, you see, because it changed somehow the labels, right? Technology, education, politics, and religion. So it's saying, yeah, this is technology. And it makes sense. It's a workshop, Hugging Face for natural language processing. Yeah? So it's technology. And then education get lower, right? So it's the same content, but then the categories change, right? And now the LLM is telling you this is more related to technology than education, right? So if we change back technology, for example, and we said sports, maybe now it's going to say again education, right? Yeah, so now we have education, sports, politics, and religion, and then back education is winner right here, right? No longer sports, thing like that, right? So we can change this now. Bad Bunny did the NFL halftime show. So now, what is this? This can be both politics, sports, or I don't know what it's going to be. So now, sports, politics, education, religion. So more likely sports. Actually, it puts always what I'm noticing here it always puts the categories, the labels ordered by probability, right? So you see sports becomes number one. So yeah, it's talking about NFL. And then we can change it. Instead of religion, show business, right? What is that? Show business, or what is it called, that category? Show. So is that a word? Show business? All right, that's it.
Concert.
So again, concert. All right, so let's change that for a concert. Thank you. Let's see what happened now. Now, things can change. That's the way this model behaves. If we change another model, maybe things are a little bit different, right? So still one concert, sports won against concert, right? So I guess, it wasn't really a concert, it was the NFL, whatever. But yeah, so I guess it's just a simple example so that you understand more or less how zero-shot classification works, right? You now can think how you can create an application that can combine sentiment analysis with zero-shot classification or one of those, right? All right. So any questions about zero-shot classification? Perhaps one thing you can do later on is to find a different model, right? Different than this one, and figure out if it behaves a little bit different, right? Any questions about zero-shot classification? Any questions or comments about zero-shot classification? No. Okay. So now let's do the next model, right? Or the next thing, named entity recognition. So what is it? So who can tell me what is named entity recognition and perhaps how it is used? Mohammed put in the chat something. Mohammed, can you tell us what is that?
Yeah, so it says name entity recognition and NLP, natural language processing, focuses on identifying and categorizing important information known as entities in text. These entities can be names of people, places, organizations, dates, etc. It helps in transforming unstructured text into structured information, which helps in tasks like text summarization, knowledge graph creation, and question answering.
Yeah, so basically what it does is takes the piece of text, right? And then recognize what entities are in the text, right? So you can create a database, a graph, more structured information, right? From simple text, you can convert it into tables, into graphs, something for the database, actually, right? Where you can put things, right? So let's see this example. This example uses this model called DSL-LIM BERT-based NER, so it's specific for name entity recognition. And let's see how it works.
Well, I have a question. Does do they use it for like resume screening?
It might. To be honest, I don't know if the uh, the tools that use for doing that, they use something like this. Definitely, they are using AI for the pre-screening your resume, right? Perhaps a combination of these, a combination of name entity recognition and summarization, a combination of different things. That would be a nice application, right? A nice application that can pre-screen resumes using this kind of technologies, So think about that. Maybe that's a good idea for you to create a resume screener, right? So the way that I envision is you can create or get a couple of job posts, right? And then several resumes, right? And analyze if the resumes match the job description, right? Some rules or using some of those kind of technology. Maybe you can do a research about how these things work and try to implement one of those. That would be a cool final project. All right. So now you see the example over here. By the way, let's remove all these messages, right? So remember what was that? I always forget. How to remove the log messages from the transformer. Right, so let's see that. I know that is login, import login, but I always forget how to put the other parts. I don't do that very often. So what is this? Yeah, this one. Import login. You need this part. So let's put it here on the top, right? And not, and then we can run this part again, right? All right. So this is the entity, right? Entity recognition. It has a couple of things. It's a list, right? You can see it's a list that has why this thing running? I don't want this. No, I don't want any of this. Can get rid of this one. I want to get rid of this one and this one. Okay. I just want this one. So it's a list that has the entity, right? Entity group. It says pair. Pair is persona, right? And score, which is a number. And the word that has that category is Ben. So it's saying basically Ben is a persona with a probability of 0.99, right? Then, and it says where it starts. It starts at the beginning of the text, 0, character 0, and ends on character 3. So ends over here, right? And then the next entity group is organization, ORG, right? So it's saying, hey, there is organization. We have with a score of 99. The word is CityTech, right? CityTech is an organization, right? It's telling you where it's in the text start at position 15 and ends at 24. And then entity group location, right? Location, it is with a probability of 99%. The word is New York City and starts at 28 and ends at 41. We could format this thing better, right? So we could use something like this for entity in well, so let's save to make it more clear, right? So we can save this thing here in the say output is equal to, this is the name of our pipeline, right? So near, and then I said categorize this thing, right? So I said that. So now for entity on output, entity on output, print entity. This is going to be a little bit nicer, not cool, but we can actually do a little bit better, right? So now you see, now we have this entity, right? A group, score, word, right? So maybe a nice way to do this would be to say for we can say word. So I want to put the word first, right? Word. I want to do the score, the entity group. This is the name of the key, entity group. And I want to say the score, right? Right, so yeah, this is score. All right, so now I think it's going to look a little bit better. So I said Ben is a person with 99. City takes an organization with 99. New York City is a location with 99. So maybe we could add a little bit. we can use F string, right? F string and say word. We can put here like this. I'm just trying to make it fancy, right? So then we can say word. We can use double quotation mark over here. We can use entity type. We can leave it like that. And finally, score. Becoming slow coding, you know, so with the AI is slow. All right, so now it looks better, I believe. Yes, word Ben, entity type, person, score 99. Word, city tech, entity type, organization, score that. So I didn't use the position where the word is in the string. I didn't care. I just care about the entity type and that thing, you know. So now I have this a little bit more structure, right? So you can check that. Let's try to find something in the news. Okay, not just because, yeah, let's use this thing, you know. I don't know what it is, you know. I'm not trying to do something political. It's just an example that I found, right? So let's put this one as text or input. Let's put it as an input. Input, and then you put this text. I just use three. All right, so that's the text. All right, what happened here? Why doesn't want this? All right, so equal. So now we got input. That's the input, right? So we are gonna do, instead of putting this, we're gonna put the input, right? The text that I just copied from the internet, and let's run it and see what do we get now. It's very poor, you know? So from all that text, it recognized Democrat which as miscellaneous and Bond as person. I don't know who Bond is, you know? Well, it wasn't, yeah, because you see Democrats, Bondi. I think he got a mistake, you know? It should be Bondi, right? No Bond, Bondi, with questions. And yeah, the rest things doesn't seem to be any entity here, you know. That was it wasn't as nice example that as I thought. Let's try to find something. Let's go back to NFL halftime show 2026 and see what they say. All right, so let's use the headline, right? So I'm going to replace the input by that thing, right? And so we had bad entity, persona, Bonnie, entity, organization. I don't know. That's a kind of word, right? Wrong. Puerto Rico, location, and Super Bowl, miscellaneous, right? Anyway, so perhaps other models do much better than this, you know? But it is what it is. It recognizes entities inside the text, okay? Yeah, Gustavo saying name entity recognition is heavily used in resume screening and automated parsing, which is ATS, the system that they are using. All right. So, any questions about name entity recognition? No? No questions. Wow. Are you guys all clear or you are not engaged? I don't know what's going on, you know, but let's move to the next part. All right. So the next part, I think we have a problem. As I remember, this part doesn't work. I believe, yes, it doesn't work, right? So I think, and you can tell me what's happening here. The next part is summarization, right? So And it says there, it's a placeholder. We need to change this to a model that actually works, you know. So it's the model exists, but it's telling you some errors. What do you think the errors are here? It doesn't matter. I thought this was the case where, yeah. So we need to find a model that does good summarization, right? So let's try to find over here. Let's go back to the tasks and then natural language processing. Here it is, summarization, right? So now it exists over there. So let's see. This is the BART large CNN, might be very big, 0.4 billions. Let's see if it works. You know, I haven't tried this one. So I'm going to replace this model with that one. Hopefully, ouch, I didn't copy. Copy the name, paste it over here. Yeah, all right. So let's see how did it go. So it says that it doesn't, you see the key error over here is telling me, okay, this model doesn't do summarization. Available tasks are any to any. Summarization is misspelled, I guess, you know, or not. No, it says available tasks are any to any, audio classification, automatic speech recognition, deep estimation, document questioning, but no summarization. That's funny because it's listed here in the summarization task, right? It was listed here, and I did summarization. It's the first one that appears over there. All right, so let's use this one, the second one, the Falcon SAI. We'll replace the model for this one and run it. No, the same thing. What is happening here? Are we still using that? This one does sentiment analysis there. So, okay, so it seems like a summarization is not here anymore. Something funny. Task summarization available tasks are any to any audio classification. It's the same thing. So summarization is not there. That is funny because it's listed. Sentiment analysis wasn't listed. This one is listed, but it's telling us that it does no longer do text summarization. It says here text summarization. Maybe I have misspelled something there. Oh, it's correct. So it says here that it should be used like that, you know? Let's see. No, it doesn't want to do that. Why? That's super funny because you see here, this is exactly what it is. Let me copy this example and run it in a different. New notebook. What is this? Syntax error. Ah, this shouldn't be there. It's not giving me an error just yet. Yeah, no longer accept that. That's funny. If you recommend it, yeah. Unknown task summarization. He doesn't want to do summarization. Ah, that's funny. So what can we do as an alternative for summarization, which is kind of the things that in somehow large language models are good for summarization, but maybe we can do well. So how then this model is no longer used, right? Because that's a task, summarization. Let's see if the community says something about that. Plugin, phase, summarization, task, not working, not found. Here it is. Let's see what they say. Trying to run an example notebook summarization, then transforming what can they do section for this chapter directly from Google Colab. However, when I try summarization, I get a task unavailable. And then people say, I suspect the major update from the transformer version 5 to 5 is primary cause. If you don't want to change your code, you can ping to B4, pip install transformer -5. However, the solution B5 works with preferable. What the review actually means. So it's saying that it's more likely collab, no, not the transformers, but there is not a fix for that. Fix in collab after installing and operating, always restart runtime. Then rerun cell from top. A long solution, but I don't think that's what I want to do. Somebody else? Yeah, the same thing. It didn't work. There is no replacement. Okay, so this sounds, maybe the solution is that one. Okay, so let's do that because this model already does summarization. Maybe we can remove the task and see if automatically it does that. No. Yep. It's the same thing. It doesn't want to do summarization. All right. So I think we have to do a little bit of what's it called? Research about how to fix that problem. But the idea, and I think there must be a way to do this. It's kind of a very common task, right? Summarization command is one of the things that our large language models are best for, right? To summarize things. So we'll do a little bit of research later on, not just to keep your time, and figure out how we can do summarization back, or if not, find an alternative. But that's what is happening right now, right? It seems like it was removed somehow. Yeah, and it is the only one that talks about the issue, right? The other ones, it's 2022, 2024. It's very old. These are very old. We'll figure it out later on. But that is the idea of text summarization, right? So the idea is that this system can create a shorter version. The example in what is calling phrase here is the example that they say here, right? So this is the sentence or the few sentences that were created from this large text, right? All right. So sorry for that. I think this thing worked before. Now is really not working. Not just the model. It's just that this task is gone. And something that I noticed, and I mentioned it a few minutes ago, is that, for example, we did sentiment analysis, right? And when we did this part over here in natural language processing, here is where it used to be what's it called? Sentiment analysis. It's not longer there. However, the task, we use it and it worked, right? But it's not listed here anymore, sentiment analysis. And summarization is listed, but it doesn't accept it, right? Something weird over there. We'll figure out what's going on later on, right? So here is another example of this, and it uses, summarized, so it uses summarize. This is for Korean text. So this one also uses the summarization keyword. So I don't know what actually happened. Again, we'll figure out later on. All right. So, but I guess this idea of summarization is more clear than the other ones that we mentioned before, right? Okay. So same thing. I want you to add a new text, a text. A new text cell, and I want you to describe on your own words what is zero shot classification, what is sentiment analysis, what is name entity recognition, and then submit the version that you have done with this with all these descriptions, right? So the explanation of what it is. I'm trying to find, here it is, clear all your outputs so that you have clear outputs over here, and then you do just the text over here, and here explain what are the following concepts, right? Sentiment analysis, zero shot classification, the ones that I have on the top. It's a list. Hmm. Have to do it manually. It's like this. All right, there you go. So I want you to explain these ones. All right. So when you complete that, you can upload it. Let's do the last notebook that I shared with you today. This is lab number 3. This one is the third notebook. Gonna download it again to my documents, and then come to Colab, unloading this new book. So this notebook introduces Gradio, right? So what is Gradio? Is this tool that allows you to create an interface, an app, right? From that you can use the models, right? You can use your own models, or you can use the models that from Hugging Face, right? But it's a kind of a simple thing to create applications such as, let me see if I can find an example. Look at this example over here, right? So you put just some element, right? And then it creates this interface. This is the code to quickly create this interface, right? And you can put buttons, you can put plots, you can put some like these tools to upload images or files, right? And following a very simple piece of code, very, very simple, right? So the one that I showed you over here, right? So it's going to do an example of text generation, right? Using the pipeline. So at this moment, you can see this is the model we are using. This is the pipeline, right? Text generation. And over here, this is the function that actually does our job, right? So calls the pipeline, right? So it has the prompt, it has the maximum number of tokens, and these are sent to the pipeline that we used before, right? So the pipeline is called with the prompt, with the maximum number of tokens, and then we sent back the result of calling the model, right? This function, generate text, was called inside the application, the demo, the interface that we are creating is kind of we call it demo, right? This is the demo that has an interface. It has a text. This is the function that we are going to use is generate text, so it's going to use this function, right? And then the inputs are a text box, right? That has a label prompt, a placeholder that says write a welcome message, and then it's going to have a slider, a slide that can change the number of tokens, from 16 to 256, with the default value equal to 64 and steps of 8. So every time you slide the bar, is going to change 8 tokens, right? And that's kind of the inputs. Then we use another text box, to put the output. What are the output? The things that returns the function, and this is the title and a short description. If you run this model, you run this quick notebook, you will see that, by the way, you can change right now. You see when notebook settings, you can change to GPU. For this one, you don't need it, to be honest, but just in case you change it to GPU, now it restarts. And you will see soon what is going on with this part. We're going to work more with radios. This is just a simple introduction so that you can see how it works, right? I suggest you have time to go into this quick start so that you have a better idea of how to do it. The nice thing is that you can work on collab, you can work offline on Jupyter Note in what's it called? Sorry, in Visual Studio Code. And also later on, we're going to talk about Hugging Face spaces, which are basically like places where you can post your applications. It's taking some time, to get all the libraries on time. There you go, right? So running the model, this is the part for the model, right? So the model that we are using is this one called TinyGPT-2. Really bad, so we can maybe later on change it. And this is the interface. Too bad that it put it on the bottom, right? But you can see this over here, you see this text that says write a welcome message to CET4973 this is the placeholder, right? And this is the text box that we call it prompt. This is the prompt, right? So this is the title prompt. This is the text box, please. So this line over here, this line over here is putting this text box with this title, with this placeholder, and that's it, right? Then the second line is creating the slider. This line over here is creating the slider. It's another input. It's a slider over here, right? The title that I use is max new tokens. And you see the default value is 16. The maximal value is 256. And this is the minimum value, the maximum value, the default value is 64. And then steps from 8. The label max new tokens is what it appears over here, right? So every time you see 64 right now, I can do something like this, 72, or I can use it like this, So it's the number of tokens, right? So I can say, hi, students. I am so glad to see you in my CET4973 class, right? All right. So, and what it does, right? Once I click the button submit, right? These inputs are going to be sent to the function. This function that we call, it's always going to be, you have to assign the function that does all the performance, right? All the job to FN, right? So now when I click submit, it's going to call the function, right? And then it's going to put the resulting value on the text box, right? Now the title over here is what appears on here. You see, it is the title. This is the short description. This is the input. When I do submit, the text that I have on the prompt is going to be sent to the function that we create, and then it's going to generate the output. It's really kind of here in the in Jupyter Notebook is not the best thing because I don't know how to make it bigger, but it would be nicer you make it longer, and then you can see this thing much better. But you see, it generates the text. Hi students, I'm so glad to see you in my CET49 class. And then it has the text. Brew, Motorola, Press, is gibberish, nothing makes sense because again, we are using the TinyGPT-2 model that we used before, which is really bad, right? So let's use one of the models that we formerly use that are much better. Like for example, the one, I forgot what's it called. The Quen Coder Next, I think that was one of them. Yeah, let's use this one. The one that Asamat and other people used before. So let's change it to, instead of this one, we're going to use this, which I believe is not too big. And then the text might be a little bit warped, right? Now, we are using it within Jupyter Notebook, right? So we can use it also in the spaces, and then you will have an app that when you go to that URL, it would show the interface over there, right? One exercise that you might do if you want to learn more about this, like for example, if I click here, now it goes to the whole demo, right? I can put welcome to the 2026 edition of the class, the CET4973 class. Hope you enjoy learning about artificial intelligence. So then I'm gonna make it a little bit bigger. I'm gonna ask for, well, shorter. Well, 64 tokens is good. And then we'll see what it comes with. All right, so here is the text. I think there is a way to make this text bigger, longer. I didn't know how to do it, but yeah, so looks, this one, we will cover topics like AI technology, AI applications, it generates text, obviously, hallucinates a lot, but that's the example. So, but you see, you can create an important, a quick graphical interface, an application that actually has a face, right? And then you can just use the models that you need to create fast prototypes, right? So if it happens that your final project is an application, an app, I would expect you to have something like this, an interface where we can actually check it and use it. Let's see if we can do something else, So here is a quick start, right? So this one uses, this example has well, it uses a model for generate images, right? And then when you click in the button, it generates the image based on the prompt, right? So maybe this one has the button generate, the text box for the prompt, and then it has a control for an image. What is the control for an image? Is the GR image, with the height. So I think we can do the same thing for the text box. Let me see where is the information for the text box. For the mm, 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 mm. Mm. This is a quick start. But where are the elements? Here it is. This is fixed input, the function that grabs the user interface, the gradient components, the output components. I want to know more about the interface, building interfaces here. Here, this is the parameter is called lines. So let's change that to our little code, right? So let's go back to our here, and the output, we're gonna put number of lines. Let's use 10 lines. See how it looks like. Yeah, so now it's longer, right? So if I click over here, you can see the app nicer, right? So the output over here. You can write whatever, it's a text generation. So you can ask maybe, I don't know if it works. I said, my mind is not working. So let's write. So I hit enter submit, and now you have that, So now the interface looks a little bit bigger, because I add 10 lines. So this is kind of how many lines on this part. All right, so this is just an example for you to start exploring, right? So the potential of this is big, so there are many things you can do with this. As you can see, there are a lot of components when you go to the Gradio version, right? So there are some examples also, right? So there are some applications. You can do sliders, you can do checkboxes, you can do dates, highlight text like this, good sentiment, bad sentiment. You have a lot of components, There is a gallery. There is a gallery. No, the gallery is just a component. I think there are some community components, guides, API. Somewhere there are some examples of applications that you can look into. But yeah, so you can do really cool stuff with this, That's it. That's it. All we have today, right? So, for this one, the last one about Gradio, right? So change the model, just change the model, and you can change one or two aspects of the interface, like the title, change the title to something else, and the placeholder, instead of saying welcome to CT4973, change it to something that you want to do, and that's it. You have to submit those few changes for that the third Jupyter notebook. I think that's all for today. I think that's all we have today. Any questions?
I have a quick question. Are all three
Sure.
notebooks due tonight at 11:59?
I'm gonna make them do tomorrow night, So I think you have enough time to do that for tomorrow night, right? Actually, as a matter of fact, I'm gonna make them available until next Monday, So next Tuesday. So you have enough time to do a good job and play a little bit more with them, okay?
And there's data camp to do as well, right?
Yeah, that cam is always there, So yeah,
Okay,
you know what follows. Yes?
got it.
Perfect. Any other question for me? All right. So I'm gonna stop the recording and